So, okay, you've made a lot of progress, and some people have already moved ahead to the proving, explaining part. So I thought what I would want to do is clarify for you the next stage of this investigation. And that is this is crooked, that is this stage. So from walking around, I'm seeing that a lot of you have convinced yourself that you're pretty sure you could make any kind of shape of a quadrilateral. You could describe what diagonals were needed in what position to make a quadrilateral. And how would you convince, how did you convince yourself? How would you convince a friend? For example, if you went to another group, could you convince a friend? How would you do that? Because in a way, we're all sort of mathematical friends. But the last step would be, how could you actually formally prove this to a skeptic? Prove your conjecture. And here's where you're going to need to draw upon all the proving skills that you know about, that you've been learning all year. So this is going to be actually the group product of your investigation. How would you prove it to a skeptic? Now, let's see. I didn't decide if I wanted you to write this down. Would you talk yourselves through this? And then when you're ready, when your group's at that stage. Not everyone's at the same stage yet. But talk yourself through this. And, I have to confess that you have made such tremendous progress on this that I was expecting that this part wouldn't come till Thursday. So I hadn't really decided what kind of product to have you do. But this is where we are going with this so that you could actually prove. I wanted to compliment Sage, because one of the things he said was that you can't assume any of these lines are parallel. You can't assume anything because it's just how it looks. And thank you for that. And we cannot assume. And Javier said the same thing. And so what we're going to want to do is, okay, we have a pretty good conjecture. Now, can we prove it? Can we prove it? It looks like it is. Can we prove that with that two configuration of diagonals, we can guarantee that we're going to get that quadrilateral, and we can prove it. All right? All right, so let's work for maybe another 10 minutes, and then we'll clean up.
The diagonals.
So these two matter.
And they're not at the midpoint.
What do you say that when
So maybe it's a ratio.
How to make a regular trapezoid? I mean, just a trapezoid?
Because alternate interior angles are different sizes.
For them to form different sizes.
I think they do have to be different sides, but
Of triangles. In this case, they form two isosceles triangles, but otherwise they shouldn't in a normal projection.
It's no data except everything is not the same. And that these are vertical angles.
But it's not working out to be.
this is just like a special trapezium. It's just some random shape, except the only thing is that the two of them are parallel.
This and this.
this and this are not
Yeah, a little bit.
Because on isosceles triangles, the two base angles are the same. And because vertical angles are always congruent to each other, these two vertical angles are the same. So the base
We already make a rule to making a consistent trapezium.
Yeah.
Yeah.
Would it be the same?
It's so odd that somewhere between trapezoid, trapezium, we get stuck.
I would have thought we'd get stuck on trapezium.
You'd think there'd be more rules.
Maybe it's just the same rule as trapezium, except that you just have to have parallel sides.
Yeah.
But why is it so hard to make it with these? We tried making it and instead we just got non-parallel. We didn't got non-trapezoids.
That could be parallelogram.
But how are you saying that these two are not parallel lines?
What?
Why can these two segments not be parallel? How can you prove that they're not parallel?
They are.
Well, no, I just put the parallel.
They look like they're going to intersect someday.
To prove that to prove that they're parallel, you have to measure the alternate interior. Okay, you know what?
Look, little something.
Dude, don't poke it.
Oh, this is an isosceles trapezoid?
How do you know the
Yeah.
side of side? Oh, you mean
That's interesting.
reflection property?
The alternate interior angles.
You're gonna write your conjecture inside the shape?
I don't know.
Look at the little sound thing on the microphone.
We figured it out. We figured out why they're parallel. You measure the alternate interior with this. Because you gave us these, so we assumed that we could. We can assume that we did.
It works for this particular case.
Well, we can do all the shapes if you want.
You could do it.
Yes.
So okay, there I'm using that word. You measured and you found that they were true, so you're convincing at that stage you're here. Right? So now.
Oh darn, I really thought I convinced you.
So what happened? So you convinced me that this particular one, but what about any trapezoid?
So if we draw all the shapes, have we convinced you?
Well, what your job is to do is to put that down on the paper. So you could convince it, like an ironclad explanation, all right?
So what if me and Dove are not mathematical friends because we don't mathematically get along? How can you explain
All right,
that?
so maybe what depends on a mathematical friend is if he came to the same conclusion you did, then you're going to be mathematical friends. If they have a different idea, then be mathematical.
He always has a different idea. We're always arguing.
Really? Okay.
Side angle.
I'm going to ask you to stop in like 1 minute.
Angle side.
Anyways, you want to know what other conjecture I made?
What?
Are you like that? Little bars on the microphone.
Now they're gonna get a bunch of tapping on their video.
Hey, that's a conjecture.
So now we have to see if it works with the other ones too.
I think it will because I have the diagonals.
Alright, then prove it. So, I'm gonna make a square.
Good for you. No, okay. I want to try it with the short one and the long one because that one looks kind of weird to me. I think we should have music then while we do this.
Resource managers, I need to talk to you.
Haha, that's not me.
Yeah, I think the square was the easiest one to prove because they're on
So if we put this back together and then we have to staple all this.
But okay, so we measure it like this. Which ones are parallel? This one's. I do the one that's not parallel. Oh my gosh.
Got it.
I wasted paper.
nice.
You could all.
JK.
This one's just a kite, no parallel lines. And we know it's a kite because it's a kite, and we know how do we know that these are the same length?
Use a ruler.
Because these two are the same length.
How do we know that? We have to measure it out.
Oh, because you already have the circles and everything.
The circles.
Because the stick told me they were.
So let's just say it's 6, and this is perfectly on 3.
So a square is a rhombus, but a rhombus is not a square. Oh snap. How do we know these are parallel? Because that's a 90-degree angle, and it's bisected into 245
You staple
degrees.
your work.
So we need to find a way.
They look the same. Bada bing, bada boom.
But yeah, but that's how we figured it. That's how we're supposed to prove it.
Go get a protractor. There's protractors over there.
I don't think we're supposed to measure it. Like,
But she gave us
Resource
protractors,
manager.
didn't she?
Go see if there's a protractor upstairs. Check that.
4.
Protractor.
And then yes. And I figured it out. Okay.
So, anyways,
So they're like another way though, instead of measuring it.
aren't you another way?
This is kind of right.
Yeah, she gave us protractor, so we're supposed to measure it, because that's how we roll, yeah. So we put, okay, this is a really gross shape.